All right. We have two lines, 2x plus 5y equals 10, 2x plus 5y equals 20, and we are asked to describe multiple vector translations that will map the first line onto the second one. Now, first of all, let's just real quick review how to graph these lines. One way is to rewrite the lines in slope-intercept form. So in that case, I would have 5y is negative 2x plus 20. I subtract 2x from each side, and then I'll divide by 5 on each side, and I get negative 2/5 x plus 4. Okay, so y-intercept of 4, 1, 2, 3, 4, and we're going down 2 over 5. So down 2 over 5, down 2 over 5. Or over here, we would have 5y equals negative 2x plus 10. So I subtract 2x from each side, divide by 5, and we get negative 2/5 x plus 2. Okay, so this time y-intercept is 2, 2, and we're going down 2 over 5. Down 2 over 5, down 2 over 5. The other method we could use is to find intercepts. So I could say, to find the y-intercept, I replace x with a 0. 5y equals 20. That eliminates that term completely, and we get divide by 5 on each side to get y equals 4. So we know that the point 0, 4 is on the line. When x is 0, y is 4. That's this point right here. Then we could say, well, I'm going to replace that 2x plus 5 times 0, replace the y with a 0 this time, equals 20. And that eliminates that term completely. Divide by 2 on each side, and x equals 10. Right? Which means that the point 10, 0 is on the line, which is out here, 10, 0. So I've got 0, 4, and 10, 0. And if I know those two lines, I can just lay the ruler down and connect them. I can also figure out what the slope is between them, and I can plot some intermediary points to make sure I have a nice straight line. Same over here. I could replace the x with a 0. 2 times 0 plus 5y equals 10. That eliminates that term. Divide by 5 on each side, and I get y equals 2, so that the point 0, 2 is on the line. So I got that point over here, 0, 2. And then I'll replace the y with a 0. 2x plus 5 times 0 equals 10. That eliminates that term completely. Divide by 2 on each side. Then x equals 5, which means that the point 5, 0 is on the line. And that point is 5, 0 right there. And again, I can just connect them with a straight line. I can use that to figure out what the slope is and going to draw some extra points. All right, so that's just how to graph those two lines so we can see what they are. So next, we want to talk about what does it mean to have a vector translation that moves one line onto another. So we're going from the blue line to the pink line in this particular case. Because we've talked about moving single points, and we've talked about moving shapes, we haven't talked about moving lines. But it's the same thing. We're just trying to come up with some sort of a vector that will move every point on this line to a point over on this line. Right? And we want to move each point to a unique point over here, right? So that not like we're going to get doubled up anywhere. So I want to imagine what would it take to shift this whole line straight up to the other one. Well, I kind of gave it away. Let's go straight up. All right, so I can go from here to straight up. And now, so it's up 2 units, up 2 units, up 2 units, up 2 units. Think about that's really, well, the difference between the two y-intercepts of 2 and 4 is just that it's the same slope, but that line's been shifted up. Right? So one possible answer is the vector 0, 2. Okay? That's one possible vector. Another one, I could shift everything over, right? I could go from here over there. So that would be the vector 1, 2, 3, 4, 5, 5, 0. So So we could go over 5 and up 0. That would work too. Now there's lots of other options as well. I could do this. I could shift every point up like that. That'd be the vector, see, negative 1, 2, 3, 4, 5. Negative 5, 1, 2, 3, 4. Up 4. And that would work as well. So I could go back 5, up 4. This point would go back 5 and up. Oh yeah, this point goes back 5, up 4, back 5, up 4. That would work as well. So there's lots of different options. Or on the other hand, I could go, let's see, shoot, here. I could take this point right here. I'm trying to do this without. I could move it all the way down here to that point there. All right, that'd be the vector. Let's see, it's down 2 and forward 10. That's 10, negative 2. So all sorts of different options. One thing to think about is there some sort of like formula that you come up with? Because I see, so I say I've got 2, I got 5, negative 5, I got 10, negative 2, 4. Lots of multiples of 2 and 5. So maybe there's some sort of a formula I could come up with for generating lots of different options. Because I mean, there are many more. I could come up with lots and lots of different ones. Just anything that shifts one point from here over to a point over there in a way that I could repeat over and over again. So all sorts of multiples of 5 and 2. Maybe there's some sort of formula I could come up with to generate all these different possibilities. So that would be something that maybe I'll leave up to you. But again, so we're just coming up with some different vectors to move this line over onto this line. And when we talk about that, we're just looking at different ways to a different translation that'll move every point here over to a corresponding point over there. Okay?